Modernage MCQs Physics class first year, unit number 3, Motion and Force, part 3. A projectile is projected with initial kinetic energy of 100 joule. In the absence of air, what will be the kinetic energy of the projectile just before hitting the ground? Option A, 100 joule. Option B, 60 joule. Option C, 40 joules. Option D, 20 joules. The key is 100 joule. Therefore, the correct option is A. Reason: in the absence of air friction, there is no loss of energy. Therefore, the kinetic energy just before hitting the ground is equal to the kinetic energy at the point of projection. Hence, the kinetic energy just before hitting the ground is 100 joule. A projectile is projected with initial momentum of 40 Newton second at an angle of 60 degree. If friction is taken 0, then what will be its momentum at the highest point? The option A, 40 Newton second. Option B, 20 Newton seconds. Option C, 10 Newton seconds. Option D, 5 Newton seconds. The key is 20 Newton seconds. Therefore, the option B is correct. Reason: the initial momentum of a projectile is Pi is equal to mvi, which is equal to 40 Newton seconds. At the highest point, the vertical component of velocity Vy is equal to 0, and the horizontal component of velocity Vx is equal to Vix, which is equal to Vi cos theta. It remains constant throughout the trajectory of the projectile. The momentum at the highest point is Pf is equal to mvix because the vertical component Vy is equal to 0. Or we can say that Pf is equal to mvi cos theta, which is equal to 40 because mvi is the initial momentum, which is equal to 40 into cos 60, which is equal to 40 into 0.5 because the cos 60 is equal to 0.5, which is equal to 20 Newton seconds. Hence, the momentum of the projectile at highest point is 20 Newton seconds. A stone is thrown at an angle of 60 degree with the x-axis having initial momentum 10 Newton seconds. What will be the direction of momentum of the stone just before hitting the ground? Option A, 60 degree. Option B, 120 degree. Option C, 270 degree. Option D, 300 degree. The key is 300 degree. Therefore, the correct option is D. Reason: the initial momentum of stone is at 60 degree with the positive x-axis in counterclockwise direction. When it hits the ground, its final momentum is also at 60 degree with positive x-axis in clockwise direction. Therefore, the direction of final momentum just before hitting the ground with positive x-axis in counterclockwise direction is 360 minus 60, which is equal to 300 degree. Hence, the direction of momentum just before hitting the ground is 300 degree with the positive x-axis. If two balls are moving along a straight line with increasing speed of recession, the balls will: option A, collide. Option B, collide elastically. Option C, not collide. Option D, collide inelastically. The key is not collide. Therefore, the correct option is C. Reason: the speed of recession is minus v1 minus v2, which is equal to v2 minus v1. As the speed of recession increases, V2 is greater than V1, the separation between the balls increases. Therefore, they do not approach each other and collide. Hence, the balls will not collide. A science museum designs an experiment to show the fall of a feather in a vertical glass vacuum tube. The time of fall from the rest is too close to 0.5 seconds. What length of the tube is? Option A 1.30 meters, option B 1.25 meters, option C 1.20 meters, option D 1.10 meters. The key is 1.25 meters. Therefore, the correct option is B. Reason: using equation x is equal to VIT plus half AT square, length of tube can be calculated as L is equal to 0 into t because the initial velocity is 0 plus 1 by 2 gt square because A is equal to the gravitational acceleration g, which is equal to 1 by 2 into 10. Here we have taken g nearly 10 instead of 9.8 into 0.5 whole square, which is equal to 5 into 0.25, which is equal to 125 meters. Hence, the length of tube is 1.25 meters. A ball is thrown vertically upward with a velocity of 4.9 meters per second. It takes 10 seconds to reach the highest point with acceleration. Option A 4.9 meter per square second. Option B minus 4.9 meter per second square. Option C 9.8 meter per second square. Option D minus 9.8 meters per second square. The key is minus 9.8 meter per second square. Therefore, the correct option is D. Reason: a ball is thrown vertically upward. It decelerates under the action of gravity. Therefore, it decelerates with acceleration g is equal to minus 9.8 meter per square second. Hence, the ball reaches the highest point with acceleration minus 9.8 meter per square seconds. Which physical quantity will produce angular acceleration alpha in a rotating body? Option A impulse, option B torque, option C force, option D inertia. The key is torque. Therefore, the correct option is B. Reason: a body can be rotated under the action of a torque. Torque is equal to R cross F, where R is the position vector, F is the applied force. The net torque tau n equal to sigma tau I acting on a body produces the angular acceleration alpha in its rotation. Hence, the angular acceleration alpha is produced by torque. A ball falls 5 meters in 1 second. In 4 seconds, it will fall. Option A 20 meters, option B 40 meters, option C 80 meters, option D 100 meters. Key is 80 meters. Therefore, the correct option is C. Reason: formula is x is equal to VIT plus half AT square. VI is 0, therefore x is equal to 1 by 2 AT square. Number 1, in first second, x is equal to 5 meter. Therefore, 5 is equal to 1 by 2 A into 1 whole square, which is equal to 0.5 A, or A is equal to 10 meter per square second. Thus, the ball falls with g is equal to 10 meter per second square and second. in 4 seconds, x is equal to 1 by 2 into 10 into 4 whole square, which is equal to 0.5 into 10 into 16, and simplification gives that it is equal to 80 meter. Hence, the ball falls 5 meter in 4 seconds and 80 meter in 4 seconds. A bomb lost into 3 pieces flying with momenta P1, P2 and P3 according to law of conservation of momentum. Option A, P1 into P2 is equal to minus P3. Option B, P2 divided by P3 is equal to minus P1. Option C, minus P1 minus P3 is equal to minus P2. Option D, P1 plus P2 is equal to minus P3. The key is P1 plus P2 is equal to minus P3. Therefore, the correct option is D. Reason: momentum of a system remains conserved whether the kinetic energy is conserved or not. The momentum before the blast is 0. Therefore, the momentum after the blast is P1 plus P2 plus P3 should be 0. Therefore, P1 plus P2 plus P3 is equal to 0, or P1 plus P2 is equal to minus P3. Hence, according to law of conservation of momentum, P1 plus P2 is equal to minus P3. A bomb blast into 3 pieces of equal masses fly with same speed when mutual angles among their momenta are: option A, 120 degree, option B, 90 degree, option C, 60 degree, option D, 30 degree. Therefore, key is 120 degree. The correct option is A. Reason: formula: R is equal to A square plus B square plus 2AB cos theta square root. The 3 pieces of equal masses of blast bomb fly with the same speed if the magnitude of the momentum of the first piece is equal to the magnitude of the momentum of the second piece is equal to the magnitude of the momentum of the third piece, which can be written as P. Putting R is equal to A, equal to B, equal to P, we have P is equal to P square plus 2P square cos theta square root, or taking P square common and cancelling it with the P on left hand side, we have 1 is equal to 2 plus 2 cos theta square root. Now taking 2 out of the square root, then we have 1 is equal to 2 square root into 1 plus cos theta square root. Now squaring both sides of this equation, we have 1 by 2 is equal to 1 plus cos theta, or cos theta is equal to 1 by 2 minus 1, which is equal to minus 1 by 2, or theta is equal to cos inverse minus 1 by 2, which can also be written as theta is equal to cos inverse minus 0.5, and it is equal to 120 degree. Hence, the momenta of 3 pieces are mutually inclined at 120 degree.